Hello and welcome to this section of the Algebra Tutor. In this section we're going to continue talking about polynomials, and specifically we're going to talk about what to do when you try to multiply polynomials together. So I'll give you a big picture roadmap. Polynomial is just a big word. It means multiple terms in an expression, right? Multiple groupings of things that are multiplied together, right? We talked about what a polynomial is. In the last section we talked about what do you do when you subtract or add them together. And basically it boils down to comparing like terms to see if you can combine them together. Now we're going to talk about what to do whenever you multiply polynomials together. And then in the next couple sections after this, we'll talk about dividing polynomials. So we're kind of relearning our basic math, how to add, subtract, multiply, and divide these giant algebra things called polynomials. So it's really not that hard when we get going. So let's say you have some simple polynomials, 3x squared times 4x cubed. Now I'm saying this is a polynomial here, multiplying by this polynomial here, but of course these are each one term, so they're very small, little insignificant polynomials, but they're being multiplied together. So what do you do here? When you have things multiplied together like this, first thing you do is multiply the numbers. 3 times 4 is 12. Okay, and then you're still going to have these variables and exponents multiplied, so for now let's just leave it as x squared times x cubed. Now we've already covered this. What do you do when you have exponents, variables that have exponents multiplied together? The bases are the same, so I can add the exponent. So it'll be x to the 5th power. And that's the answer, 12 times x to the 5th power. So you multiply the numbers, and you basically are multiplying the terms that have the exponents as well. In this case, we know that we can add the exponent, so there you go, 12x to the 5th. So it's building on really something we have discussed previously. Now this is a very simple problem. We're going to get into larger polynomials and how to handle that here in just a few minutes. But for now, let's say we had something like 2 times x squared times y to the 3rd multiplied by 3x cubed times y squared, something like this. So again, there's no plus or minus signs anywhere, so these are not very large. This is a single term polynomial called a monomial. This is a multiplied by another monomial. So you have numbers. 2 times 3 you do first is 6. And then basically you start multiplying both of these guys times both of these guys, but you'll eventually notice that you'll have x squared times x cubed. They have the same base, so you can just add the exponents, x to the 5th, just like before. And then you're also multiplying y cubed times y squared. I have the same base, so I just add the exponents. 3 plus 2 over here is 5. So I have 6x to the 5th times y to the 5th. Right? So anytime I'm multiplying terms together that have exponents, if they have the same base, I can just add the exponents together. And that's something we've learned before. We're just kind of introducing it again here more as a review, but also so that you will have the foundation to continue on with some of these other problems in a minute. Now what if we had x squared times y cubed all raised to the 5th power? And we've done problems like this before. We have two things going on here. First, we have two items in here in the parentheses, and we have the exponent there. So the exponent is going to be applied to each of the terms inside. So we have x squared raised to the 5th power times y cubed, also raised to the 5th power because it applies to each guy. Now that we have it written out like this, you can see that for the first one you have a power raised to a power. So you multiply the powers. 2 times 5 is 10. Here we have 3 times 5, so we're going to get 15. So x to the 10th, y to the 15th. So really you're using things we've learned before in some of these review problems. Now, let's just kind of inch up our way to the larger ones. What if you have 3 times x plus 4? Well, you have a number outside of a parenthesis, so it gets distributed in. So what you'll have is 3x plus 3 times 4 is 12. So you distribute this guy in. Now let's ratchet it up a little bit. Let's say we have 3x on the outside and then x minus 2 on the inside. Now you can kind of think of these as polynomials that are being multiplied together. This is a polynomial with two terms inside. The first one is this one, the second one is this one. This is a polynomial outside with only one term. So even though this might look familiar from some of the previous problems we've done in last sections and sections before this one, really it's kind of like a polynomial multiplied by a larger polynomial. But in any case, what we're doing here is what we've done all along. We take everything outside and we have to kind of distribute it in to everything on the inside. So what you're going to get, 3x times x is 3x squared, because x times x is x squared. And then you have a minus sign that comes from here. 3x times 2 is 6, and x comes along for the ride because there's no other x, there's nothing to add it to. There's no other exponent to add it to, so it just kind of comes along for the ride. So you're going to get 3x squared minus 6x. So basically here we multiply this times the x, giving us this, and then we have this multiplied times the negative 2 to give us this guy over here. So we're slowly, believe it or not, increasing the complexity of these multiplications as we go here. And we're going to gradually increase our skills. Let's say we have 3 times x times y times x plus y. I'm not sure we've ever done one quite this big before, but it's no big deal. You have a parentheses with two terms inside. So this is like a binomial. This is like a monomial on the outside, but you have lots of things multiplied together out here. So you're basically going to do the same thing that we always do. You're taking everything outside, and you're going to multiply it times everything inside like this. So what you're going to have, to be absolutely explicit, you're going to take this 3 times x times y and multiply it times x. And then you're going to have plus because of this plus, and you're going to take this again, 3 times x times y, and you're going to distribute it into this y. Just to be absolutely clear. And so when we simplify all of this, 3 times x times y times x, you're going to get 3 times x squared y, because x times x, the bases are the same, we add the exponents, everything else comes along for the ride, plus over here we're going to get 3 times x times y squared, because y times y will give us y squared, everything else comes along for the ride. So the answer is 3x squared y plus 3xy squared. All right, now let's get into some, I think, newer material. What if you have x plus y multiplied by a plus b? All right, now this is different. This is different than anything we've done before right here, because up until now we've had kind of one thing on the outside of the parentheses. Could have some stuff multiplied together, but it's one kind of term out there. And you open up your parentheses and you've got some stuff add together in there. We know that we have to distribute everything in. That's what we've been doing on the previous board. This is a little bit different because what I have out in front of this set of parentheses is actually a larger polynomial with two terms. So a lot of students, when they see this, rightly so, don't have any idea how to proceed. And so it's a little bit cumbersome at first. So what I'm going to do is show you how to do this using only what we already know so far. And then I'm going to generalize it to what you probably have heard in your class called the FOIL method that your teachers are probably teaching you. A lot of students learn the FOIL method and they kind of understand what FOIL is. It's a way to multiply things, basically. But what they don't understand is, where does it come from? Where does FOIL come from? Why did they just make this FOIL up? So every student learns the FOIL method of multiplying polynomials in algebra class, but you don't really ever learn about where it comes from or the fact that it's something that makes total sense based on what we've been doing so far. So what I'm going to do here is show you how to multiply these things together and then show you how it ties into what we call the FOIL method in a few minutes. So notice we have this set of parentheses and we have another set out front. What you need to do is treat this out front as as its own thing, and what you're going to do is distribute it in like this, right? So this makes sense based on what we've been doing so far. So it's not a new rule, it's just whatever's out in front, you distribute the whole thing in. So the way you would do this, all right, is you would have x plus y times a, because they're multiplying it times a. And then you would have plus x plus y, and you'll be multiplying it times b. So that is what happens when you distribute it in. But when you do that, you realize that you can distribute this a in like this, and you can distribute this b in like this, right? Because everything's multiplied together. So really what you end up with is a times x, because ax, plus a times y, ay, plus, here we have bx plus by, because we're just distributing these guys in. So here I have 4 terms, right? This represents the original thing that we were trying to multiply together, right? And we did it using all the ways and the methods that we used before. We take the thing on the outside, we distribute it in, then we realize we can distribute a second time. All right, so when you think about this, right, a times x is the multiplication of these two terms. These are called the first terms, right, the f terms. So let me put an f here. All right. Over here, by, these are the last terms. When I say first and last, I mean this is the first term, this is the last term in this guy. This is the first term, this is the last term. So we take both of these and multiply the both first terms together. We take both of these and multiply, these are the last terms together, right? And over here, a times y, these guys, these are what we call the inside terms because they're kind of close together on the inside. And these guys right here, the b and the x, these are the outside terms because they're far apart. So you have FIOL. And if you rearrange this, because everything's added together, so you can kind of rearrange these terms, what you can really get is FOIL, which is called FOIL. This is the way you typically learn how to multiply something like this in algebra. The teacher tells you, or the textbook tells you, multiply the first terms together, then the outside terms, then the inside terms, then the last terms, and you add them all together. So you have plus signs in here. And when you do all of these little multiplications and string them along, that's what you get when you multiply two polynomials like this, two binomials. These are binomials because I have two terms here and two terms here. So this is fine. Using the FOIL method is fine. It's a great way to remember how to do it. But I just wanted to make sure you know that the FOIL method doesn't come out of thin air. It doesn't just pop up as a new rule in algebra. Suddenly you have to memorize a new rule. You know, students think there's lots of rules in algebra and there's so many to deal with. Well, really, there's not that many rules. They just build on each other and they get generalized. So this comes from just regular old distribution, just like we've been doing before. So I just wanted to make sure you know that. So let me erase the board, and what we're going to do next is work a FOIL problem. Actually, we're going to work several problems where we're going to multiply using the FOIL method. All right, what if I have a plus 4 times a plus 5, and I want to multiply these together? Well, I could certainly do exactly what I did before. I could treat this as one unit. I can multiply to a, treat it as a unit, multiply times the 5, and then I could simplify the answer and add everything up, and that is correct. That is absolutely correct, and if that is the way for you to remember this, that is fine. But I am going to teach you to do it with the FOIL method because it is easy to remember, and also because most teachers are going to kind of insist that you know you know what it's talking about. So when you see a binomial multiplied by a binomial, you pretty much are going to use the FOIL method. So it's very simple. First, we have to spell FOIL, F-O-I-L, right? So the first terms are going to be the first of each of the first terms inside the parentheses. So a times a. We're going to multiply that together, and we're going to get a squared, because that's what a times a is. Then we're going to do the outside terms. The outside terms are the ones on the ends. A times 5, you can rearrange that to 5a. Then we're going to do the inside terms. 4 times a is 4a. And then we're going to do the last terms. 4 times 5 is 20. And everything is added together with plus signs because there's no negative numbers or anything in there. And so the answer is a squared plus 5a plus 4a plus 20. However, you'll notice I have a like term here and a like term here. So I can simplify this. A squared plus, this is like with this, so 5 plus 4 is 9a plus 20. So the answer to this multiplication is a squared plus 9a plus 20. So I want to stress that using the FOIL method is fine. First terms, outside, inside, last, that's fine. But it all comes from just basic distribution of whatever's on the outside in. It's just a shortcut way to remember that. It's not a new rule, it's not a new lesson, it's not really anything new. It's just a way for you to remember without having, you know, because some students will get confused on this kind of stuff, but I tried to present it in a way that wouldn't necessarily confuse you. So for our next problem, let's say we have 3x minus 2 multiplied by x plus 4. And so here I have a binomial here and a binomial here. So anytime you see a binomial times a binomial, you're going to have to use the FOIL method, or if you want, you can distribute it in just like what I showed you, but the FOIL method's probably a little bit easier. So what you're going to do is hit an equal sign here. First, you have to spell FOIL. So the first terms come first, F. So the first thing we need to do is look at our first terms. The first terms in each set of these parentheses, 3x, and multiply it times x. So what we're going to get is 3 times x squared, because x times x gives you x squared. Next, you look at the outside terms, right? 3x times 4 is going to give you, it's positive 3x and positive 4, so positive 12x. Just multiplying the outside terms. Then you look at the inside terms. Now don't forget, this is a negative 2 because you have a negative sign here. So negative 2 times x is going to give you negative 2x. Right? And then you have the last terms, these guys here. Negative 2 times 4 is negative 8. All right, so that is the answer after you do the multiplication. But you're always going to be able to simplify these things because you have a like term and a like term. I have x terms there. So I'm going to have 3x squared plus 12 minus 2 is 10x minus 8. So the answer is 3x squared plus 10x minus 8. All right, so now we're cooking, and we're just going to get a lot more practice. 2a plus 4 times 3a minus 5, and we just need to multiply these guys together. So again, we have binomial times binomial, so we're going to use the FOIL method. So we identify the first terms. These are the first terms, 2a times 3a. 2 times 3 is 6, a times a is a squared. And then we go to the outside terms. These are the outside terms. 2a times negative 5 gives me negative 10a. This 2 times 5 is 10. Of course, you have a negative, and then you have the a there. And then you have the inside terms, FOIL. 4 times 3 is 12a. It's positive because I have positive numbers in both places. And then I have the last terms. These are the last terms. Negative 5 times 4 is negative 20. All right, and so that's basically the result of the multiplication, but as always, I'm going to have some like terms here. So what I'm going to have is 6a squared. This is a like term with this. What's negative 10 plus 12? If it helps you, you can flip it around and say 12 minus 10. That's going to give me positive 2a minus 20. So basically, you add these coefficients together, you keep the variable along for the ride, just like we did in the last couple sections, and there you go, 6a squared plus 2a minus 20, and that is the answer. All right, now what if we have another problem? Let's say we have 2 times t plus 3s, 3t minus s. I have this problem here mostly to show you that you don't have to have numbers only in the second spot. It could be anything in here. This is a 2-term polynomial. It's called a binomial. Here you have a binomial. But you use the FOIL method no matter what you actually have inside of here, letters or numbers. So first you identify the first terms, these guys. 2 times 3 is 6. T times t is t squared. All right? And then you look at the outside terms. Here you have 2t times a negative s. So you have a negative times positive. So you have negative 2ts. All right? The negative comes from the fact that it's a negative s times a positive 2. Negative times positive gives you negative. The inside terms, you have 3 times 3 is 9. And then you have s times t. But I'm going to write it as t times s because I know I'm going to want to combine him later. And you can flip, since they're multiplied, you can flip it either way you want when you do multiplication. And the last terms, you have 3s times negative s. So you have negative 3s squared because s times s is s squared. So those are the results of the multiplication. I have a like term here with a like term there. So what I'm going to have is 6 times t squared. What is negative 2 plus 9? It's going to give you 7 ts minus 3s squared. Now all of these are different terms, so I can't combine them anymore. None of them match, so this is the final answer. And the bottom line, if you haven't seen the pattern up to now, most of the time when you're multiplying binomial times binomial, you're going to get something, you're going to simplify some like terms, and you're going to end up with 3 terms in the answer almost all of the time. Okay, what if you have simply x plus y times x plus z? Binomial times binomial. It's the same story, different chapter every time. First terms, x times x gives you x squared. Outside terms, x times z gives you xz. Inside terms, y times x gives you y times x. There's nothing much more to do there. And then the last terms are these guys, y times z. right? So y times z. So in this particular case, you can't simplify anything after you do the initial multiplication because here you have x squared, xz, yx, and yz. So none of them match. Even if you try to flip any of them backwards around, none of them match. So the final answer is x squared plus xz plus yx plus yz. And that's the final answer. So what if you have something a little bit bigger, like 4 times t minus u, negative 3t plus u, like this. So what you're going to have is the first terms, these guys. 4 times negative 3 is negative 12, and t times t gives you t squared. And then you have the outside terms. 4t times u is going to give you 4tu. Can't really do much more with those because they're different variables. The inside terms, negative u times negative 3t is going to actually give you a positive because negative times negative is positive. And then you have 3tu. I mean, you could write it as ut, but I'm going to flip it backwards because I want it to match one of my other guys so I can combine them later on. So 3 times t times u. As long as you have all of them there, you're fine. And then you have the last terms. Positive u times negative u is going to give you negative. U times u is u squared. So here's what we have, but notice that I have some like terms. That's a like term with this because I have tu and tu in both places. So finally, I'm going to have negative 12t squared. 4 plus 3 is 7tu minus u squared from over here. This is the final answer. Negative 12t squared plus 7tu minus u squared. All right, here I have r plus 4 times r minus 4. All right, not too bad, but I want to make sure and do this one for you to make sure that you understand and kind of see something here. Okay, first terms are going to be r times r is going to give me r squared. Outside terms, r times negative 4 is negative 4r. Inside terms, 4 times r is 4r. And the last terms, 4 times negative 4 is negative 16. So here we go. Now I look for like terms, and I immediately see I have a negative 4r and a positive 4r. So really, 4 minus 4 subtracts to give me 0. So what I'm left with is r squared minus 16. That is the final answer. And I just wanted to point this out to you because, normally whenever you do these multiplications, you're going to get some kind of like terms. And so most of the time when you combine everything, you'll have 3 terms in your answer. That's mostly what we've had. But occasionally, if you get a cancellation like this, it could wipe itself out and you only have 2 terms in the answer. So not something you have to memorize. I was just pointing it out to you to show you that depending on how the things add in the middle, you might have a term drop out like we have here. All right. Now let's switch gears a little bit. I think we've done enough of the FOIL method to show you that it's pretty easy. You have a binomial times binomial. I showed you how to multiply it. I even showed you where it came from, which is just basically distribution in. So what if you're given something that looks a little bit crazy like this? 4 times t plus 3 multiplied by t squared plus 2 times t plus 3. Now this is totally different than anything we've done in this lesson because typically we've had binomial times binomial. Here we have binomial times trinomial. And this is not something you're asked to do too often because a lot of students choke and don't know how to proceed. You immediately know that you can't do FOIL on this. At least you can't do it with FOIL because you have too many terms over here. So FOIL only applies if you have binomial times binomial. That way you have FOIL. It only applies as a memory mnemonic, as a memory helper, when you have binomial times binomial. So here we have binomial times trinomial, so FOIL is going to not really help us because it's set up for that special case. And I distribute it into here, distribute it into here, and distribute it into here, right? And that is true. You could definitely do it that way. Let me show you another way, just to kind of not really blow your mind, but just show you that algebra makes sense. So we could definitely take this unit and multiply times this unit times this unit times this, but we can also do it like this. I can take the 4t, I can multiply it in like this, and then I can take the 4t to here, and I can take the 4t into here. And then after I'm done with that, I could take the 3 and multiply it into here, and take the 3 and multiply it into here, and take the 3 and multiply it into here. Basically, forget for a second that I have 4t plus 3. If I only had the 3 out here, it's very simple. You have to take the 3 times this, the 3 times this, and the 3 times this. That's what we've been doing all this time in algebra. If I cover up the 3, it's very simple. The 4t has to be multiplied times this, the 4t has to go times this, the 4t has to go times this. The fact that I have them added together just means that both of those things have to happen in order to do this multiplication. If you have two terms multiplied on the outside of a large parenthesis, every one of these outside terms that you have has to get distributed and multiplied into the inside. This has to happen as well. So it's kind of, again, it's not really a new rule. A lot of people say, oh, it's a new rule in algebra, a new rule, it's so complicated. It's not complicated. Everything on the outside has to get multiplied to the inside. Every term has to be multiplied by every other term, and this is the easiest way to do it. So let's just do it, just to show you how to do that. All right? 4t times t squared. Well, that's going to be 4t cubed, because t times t squared is going to give me t cubed, like this. Now, 4t times 2t. 2 times 4 is 8. T times t is t squared. Now, 4t times 3. 4 times 3 is 12 times t, because t is hanging along for the ride. Okay, so what I've done is I've pretended at this point that the 3 is gone, and I distribute everything in, and this is what I get. Now I have to keep going. Plus, I pretend this is gone, and I take the 3, multiply it times t squared. I'm going to get 3t squared. If I take the 3 and multiply times 2t, I'm going to get 6 times t, because 2 times 3 is 6. And if I take the 3 times the 3, I'm going to get a 9. So what I've done is these three things arise from taking the 4t and multiplying in, and these three things arise from taking these guys and multiplying in. Everything out in front has to cross-multiply into everything on the inside. So now I look for like terms. Well, I don't have any other t cubes anywhere here. So it's going to be 4t cubed. That just stays along for the ride. But I have a t squared here and a t squared here, right? So these match. These are like terms. So 8 plus 3 is 11. 11 what? 11t squared. All right? And then I look for any other like terms. I have a 12t here and I have a 6t here, right? So these are like terms, t and t. So 12 plus 6 is 18t. Right, so those guys there. And then I just have a number. There are no other numbers here, so I just have plus 9 at the end. So the final answer is 4t cubed plus 11t squared plus 18t plus 9. And that's the answer. So most students, if you're given this on a test, if you don't know what you're doing, then you kind of get lost, because they don't know how to use FOIL for it. And if you don't know how to use FOIL, see, that's the danger of FOIL. FOIL's cool, but it can get, you can lean on it too much, where you don't know what's really happening. FOIL only comes about because you're multiplying everything on the outside times everything on the inside, and then you simplify everything. And so when you make a larger problem, the same thing happens. And so just to kind of, just for giggles, if I continued this and I had, plus, z plus w over here, so I had a much larger, polynomial here, then this problem, now that you know how it works, is very simple. So the 4t gets multiplied times this, times this, times this, and then also needs to get multiplied times this, and then also times this. And then the 3 needs to get multiplied times this, 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 and then also times this, and times this. And then you have a lot of terms that you have to then simplify. So once you know the big picture, then multiplying polynomials in algebra is really just following the same rule, just to larger and larger problems. All right, up till now, we have done multiplying polynomials, just for the sake of it. But they can actually come in handy when you're trying to solve more complicated equations. So here we're just going to take a couple of quick equations to show you how you can use what you've learned to solve some equations. So what if you have s minus 4 times s plus 1 is equal to s squared plus 5? Before knowing how to do any of this multiplication, you wouldn't even know how to attack this. How do you solve for s? Right? You want to get s by itself, but you have all this stuff wrapped up. You can't do it unless you multiply and collect all of the like terms together. So here, you just go ahead and you do your FOIL, right? Here's the first term. S times s is s squared. The outside terms, s times 1 is s. The inside term is negative 4s. In the last term, negative 4 times 1 is negative 4. On the right-hand side, you have s squared plus 5. So you want to collect like terms. So you notice that you have an s squared here and an s squared here. So you want to go ahead and combine those guys. So the way you would do it is you'd subtract s squared from this side, move it over here, but you remember that as soon as you do that, basically s squared goes away. Because we have s squared on the left and s squared on the right. So if I try to subtract s squared from both sides, they're just going to disappear from both sides. So it's gone, right? It's gone. So that you can just kind of disregard that. The only thing I have left now is s minus 4s minus 4 is equal to 5, right? Now on the left-hand side, I see I have an s minus 4s. So these are like terms, s and s. So what is s minus 4s? It's going to be negative 3s because you subtract them. 4 minus 1 gives you 3. Negative comes from the bigger number. Minus 4 is equal to 5. Now, we want to eventually solve for s, so let's move the 4 over here by adding 4. We're doing the opposite. Negative 3s, we add 4 here, that gets rid of it. On the right-hand side, we add the 4. So we add 4 to both sides, so we get negative 3s is equal to 9. And now, with the grand finale, is we get s by itself by dividing both sides by negative 3, because there's a negative here. So it's 9 over negative 3. On the left, it cancels and gives us 1. On the right, s is equal, 9 divided by negative 3 is negative 3. So the answer here is negative 3. So this would be hopeless to solve unless you knew how to multiply these. You wouldn't know how to isolate it. Students would just kind of go bonkers. But if you expand it out, collect the like terms together, get s all by itself, then you're actually able to isolate it and solve. All right, for our last problem, we're going to learn how to solve an equation that looks like this. X plus 4 times x minus 4 equals x minus 2, x plus 6. Again, if you didn't know how to multiply polynomials, this would kind of look hopeless. You wouldn't know where to begin. But now you know when you have these here, you have to multiply them. So let's multiply the left. First terms, x times x gives you x squared. Outside terms, x times negative 4 is negative 4x. Inside terms, positive 4x. Last terms, negative 4 times positive 4 is negative 16. On the right-hand side of the equal sign, we have to do the same thing. First terms, x times x is x squared. Outside terms, x times 6 is 6x. Inside terms, negative 2 times x is negative 2x. And last terms, negative 2 times 6 is negative 12. So we do FOIL on both sides of the equal sign because that's how we have the multiplication set up. All right. Now we look and we try to collect terms, and we notice right away that we have an x squared on the left and we have an x squared on the right. So because of that, they're basically going to cancel out. If I try to subtract x squared from both sides, they're going to both disappear, right? And we also notice that I have on the left-hand side negative 4x and positive 4x. These are like terms that I can add together, but since negative 4 plus 4 is 0, both of these basically disappear as well. So on the left-hand side of the equal sign, all I really have that's left is negative 16. On the right-hand side, I have 6x minus 2x minus 12. But then I notice right away that I can simplify these terms on the right-hand side because they both involve x. So I have negative 16 is equal. 6 minus 2 is 4x minus 12. So now we're finally getting here. So since x is already here, let's leave it there. Let's take the 12 and move it to the other side by adding 12. So we have negative 16 plus 12 is equal to 4x. We basically add 12 to both sides and it disappears from the right-hand side. Now when we add this, what's negative 16 plus 12? I think you'd agree it's negative 4. Because basically we subtract them and get 4, and the negative sign comes from the bigger number. And on the right-hand side we have 4x. Okay, so let's actually just do this. Actually, I don't need any of these equal signs like this, actually, because I have the equal sign here. All right, and then to get x by itself, we divide by 4. So we'll have negative 4 divided by 4 is equal to x. So we divide by 4, it goes away there. And then finally, negative 4 divided by 4 is negative 1 is equal to x. So it doesn't matter when you solve an equation what side of the equal sign x is on. Here we have -1 is equal to x, so you can rewrite that if you're happy to do that and say x is equal to -1. Whatever side of the equal sign x is on, whatever's easier for you, just get it by itself. And if you leave it like that, that's fine. If you want to rewrite it and say x is equal to -1, that's fine too. But either way, that's how you do the problem. So we are done with this section. This was multiplying polynomials. We started out basic. We started out with really simple multiplications that just involved exponents. And then we got bigger and bigger and finally got to the point where we're multiplying binomial times binomial. And I tried to tell you, okay, you learn about the FOIL method. And we did the FOIL method. We practiced it. But I'm trying to drill it in that the FOIL method is nothing more than just distributing all these terms inside the parentheses. And that's a lot of students get confused in algebra where all the rules come from. It's a great example of really, it's no new rule. It's just an easy way for you to remember it that all of the books have you remember. And it's easily extensible to if you get larger multiplication problems, you know what to do, which is another advantage of really understanding what's going on. So make sure you can solve these problems and work extra problems in your book. Check your work. Go watch this video again, work all of these. Multiplying polynomials is so important. You'll be using it constantly. And then once you master this, follow me out to the next section where we're going to begin to learn how to divide polynomials, which you'll find out is not that big of a deal once we get some good examples and some good practice.